So this is the first of a series of films where we're going to look at how to apply the rules in the rulebook for the limit, to compute limits. And what do I mean by the rulebook? So the rulebook says that if, for instance, an goes to L and Bn goes to M, then this implies that An plus Bn goes to L plus M. And if I do the minus here, I get the minus here. If I do multiplication here, I do multiplication here. If I do division here, I get division here, given that these bn's are non-zero and the m is non-zero. So these are some of the rules in this rulebook. You can basically look in any math or calculus book you want, and then you'll get the list of all the basic rules. So you have the squeeze theorem, and then you have the limits for composition, and that's basically it. Now, how to apply these rules to safely compute that the limit of n minus n squared divided by n plus 2 is equal to 2. So we saw that this was a bit dangerous to do intuitively. And well, let's even assume we don't know the answer to begin with. So what to do? Well, here we have a difference between two expressions, but they don't both converge. So we're not allowed to say that this is equal to the limit of this minus the limit of this. So the rulebook is not telling us directly how to deal with this. What's the response? Well, the response is to rewrite this using algebra until it turns into something that we can deal with. So this is basically the rulebook telling us put things on a common denominator. So that's like a rule of thumb that quotients are good, okay? Sums and differences usually bad, quotients good. So it's something that a Stone Age person could understand. So now we simplify as we did before, and we are getting here 2n divided by n plus 2. N goes to infinity. Now here we still have something going to infinity and something going to infinity. So we can actually, so this is an indeterminate form where we have something going to infinity divided by something going to infinity, which means, well, anything can happen, anything goes. And let's see what happens in this case. Now, as I said, so this doesn't have a limit, this doesn't have a limit, so the rulebook is still not allowing us to do anything with this. We still have to rewrite it. But then comes the trick. Who is the strongest up here and who is the strongest down here? Well, the n is kind of calling the shots up here and is also calling the shots down here. So let's factor out the strongest guy in the denominator and numerator. Okay, so we take out the n here and the n here. We're left with a 2 on top and a 1 plus 2 divided by n down below. We cancel these two guys, and now the limit has finally turned into something that our rulebook can handle. Because now 2 is a constant, so he has the limit 2. So you can say in this rulebook here, we kind of need two rules to begin with. So the limit of a constant is equal to the constant itself, and then the limit of 1 over n is equal to 0, as n tends to infinity in both, of course. So this means that we know that this has the limit 2, and we know here, well, here we have a sum of two guys, but this guy is a 1, he has the limit 1, and this guy here, well, he's a product, 2 times 1 over n. Well, this is a product between 2, who has the limit 2, and 1 over n, who has the limit 0. So everything now here can be thought of as being composed by stuff that has limits. So if I want to do this really, really carefully now, I would say that this is now the limit of 2 up here. Let me not write n goes to infinity everywhere. Down here, this is the limit of 1 plus 2 divided by n. And then I could split, so this is just the 2. And down here, I can do the limit of 1 plus the limit 2 divided by n, like this. Now this just has the limit 1. And now this is the limit 2 times the limit 1 over n. And we have a 2 here, we have a 1 here, 2 here, and then a 0 here. And then finally, this gives us 2. And you can notice kind of a perversity here. So how can I justify each and every step here? Well, I'm basically justifying these steps while backtracking, okay? Because here I have 2, which I can express like this. And now this thing here has the limit 2, this thing here has the limit 0. So I know that he and he separately have limits. So I can combine them using the rulebook to this, right? I have 1 here, but here's the limit of 1. And now, since I know that this has a limit, I know that this has a limit, since I kind of saw it down here, I can combine these two to get this. Now 2 is the limit of himself, so this I can write like this. And now I know that all of this has a limit. I saw it down here, and I know that he has a limit, so I can take the limit outside. So I can use the fact that the limit of a fraction, where this thing and this thing both have limits, can be written as the limit of the guy on top divided by the limit of the guy below. So when I'm moving forwards here, I actually don't know if I'm justified until I actually see that it works. But this is a completely normal way of doing things. So just do the stuff that you think is correct or hope is correct. And once you finally arrive at, or once you finally resolve all the limits, then you are fine. Then you justified everything you just did. And if here something doesn't exist, well, then you say it up here. Okay, this method is going to fail because then either you have to rewrite stuff or you have to realize that what you're dealing with does not have a limit. And of course, this is not something you'll do in this detail ever, I would say, because when you look at this, as I said first, you realize what's going on. And I would say here in the normal answer, don't do all of this. Just say that this is 2 plus 1 over 0, which is equal to 2. Because when you write it in this way, then you're telling the reader that you know what's going on. So this has the limit 2, this has the limit 1, and this goes to 0. So then you're fine like this. But it's a nice exercise to at least once have picked it apart into its smallest pieces like this.